So where's my again? So get this our last class we talked about still at introduction to analytics in R, and I think let me see again. Yeah. So currently I talked about let's talk about this. Okay, probably let me just go by it again. So let me just start from the beginning. Okay, I think I've talked about maybe that. So we have all this data structure in R. We have vectors, we have matrices, we have lists, we have data. So vector is one dimensional, matrices are two-dimensional array. So vectors can only take one data type at a time. So it's all characters or numeric. Also the same thing as matrices. But for lists can take in any value. I mean, you can put in matrices, you can put in vectors, you can put data frames inside a list. So as for data frame is just like a spreadsheet kind of data. Each column is unique to its data type. Each column in a data frame cannot have more than one data type. It's just only one kind of data type. But several columns can have several kind of data types. So it's not just only one data type. So that's about data frame. So let's look at the next slide. So how can we subset data from all these data structure? Now we have different kind of subsetting. We have the $sign, which is usually commonly used with a list and data frame. So if you're using with a data frame, you can only call a particular column at a time, and the results are going to have a vector. You can also use it to call elements in a list also. So you can only use to call one object at a time. But for these double square brackets, it's majorly most time used with data frames and lists. I don't really think if you are working with JSON format kind of data too. So but they didn't talk about JSON format, you can use this double square bracket too. So the last one works with data frames, works with I think it works with lists too, works with vectors, works with matrices. So that's the single square bracket. For example, this is an inbuilt data set in R, the iris data set. So if I'm running this, it means I want to retrieve everything beside the comma, that's to the left of the comma, correspond to the rows, while to the right of the comma correspond to the column. So if I put 1:5 just to the left of the comma, it means I want all the rows from row 1 to row 5. If I'm not putting anything at the right of the comma, it means I want every column to be returned in that regard. So that's why it says retrieve the first 5 rows and all columns in iris. Should I use my PMO? Let me use my PMO. But yeah, PMO station. So okay, moving to the next slide. Now you can also use the word sample subset. Sample it's maybe important when you want to generate just a subset of the data set. Maybe randomly you can use this sample function to do that. So look at this scenario, for example. I use the sample functions for the vector 1 to 6. So I said I want size 10. That is, I just want 10 sample size. So replace equals true means that out of this 1 to 6, I'll pick at random one number from 1 to 6. I'll do this 10 times, but I'll replace it with replacements. So what it means that from 1 to 6, if I pick 2 now, it means I'll replace that 2 again. I'll pick again So it's possible I pick a 2 again. So as you can see here, that I pick a 5. So I'll do this 10 times. So this generates like 10 random numbers with replacement. So that's the function of the sample. Let me put my virtual machine. Okay, when this is on, we continue. So I think I've already explained this. So let's look at the next slide. Now, if I should go back to the previous slide, you see here that this sample generates random set of number. Now, the reason I'm putting set.seed here is that I make sure I want to repeat this process over and over again, and I want to get the same result. So I'll use this set.seed. So if I use set.seed equals set, I put something inside it. So it means that, like this case, I put 1. So if I do this sampling, if I generate this set of number, if I want to generate it again and I set the seed to be 1 also, I also generate this set of number. But if I don't set this seed, if I should run this sample function again, I'm going to generate another kind of sample entirely. So that's the essence of using this sample set. So let me log into this. Right? Let me enlarge it my screen. It's not enlarging. So let me open my RStudio. So that's the essence of using the set.seed. Now, what would be the correct syntax for the command to take samples of a coin that is tossed 5 times? So sample is where a coin is head and tail. So a sample H and T, sample size is 5, then a set replacement equals to true. So this is the correct syntax. So if you set replace equals to false, you won't be able to generate by sample because it's only have two outcomes, which is head and tail. So if I don't put replace equals to true, it means I'll just generate head and tail. It's only two outcome I'll be able to generate. Hello. Oh. Okay, caller is on the call.
Manuel.
Yep.
Class never starts.
Class has started now.
Jesus Christ. There's no one in class.
Mary is in class, but because we are together, it's not. Petra said she has a meeting with that he was going to join.
Yeah, everyone is busy. There are meetings going on everywhere. Even we just finished, we just concluded the meeting now.
So she said she's probably joining meeting. So okay. So this is the essence of the sample function. So here I want to generate a sample of experiment using a coin. So I want to generate 5 results. So that's why this is specifying 5. Then this is the sample head or tail. Then replace equals to true. So this is going to generate head or tail for you 5 times. So and I mentioned something like set.seed. That if you want to generate the same result at the same time, you have to set this seed. So let me go to my RStudio here. So for instance, if I should run that command, you can see my screen, right? Hello, caller. Okay, I don't think it's anybody. So if I say sample, say H percent T, then I add a cube, then I say 5, the sample of 5, then I say okay, replace is true. Replace is equals true. So I just use this T. So let me see what this gives me. An error, it said object H not found. So apparently I have to use a quote here. So let's try with a quote and run this again. Say error, blah blah blah. So the reason is that I'm using a vector function. This might not really work out. But looking at it from the let me check again. This is absolutely what it did, but it might not really work out that way. So let's put this inside the vector, inside combine function. So combine H and be true. So let's run this. So as you can see, it generated for me this guy true. Sorry, tail, head, tail. All right, so let's take for instance, if I should run this again, you can see another result entirely. So that's the importance of doing set.seed. So if you want to generate the same result anytime you run this, you have to set seed. So let's say set.seed. So if I set.seed, I put 10 here, and I run this command, then I run this sample statement. I have this. Now if I should want to run this again, I'll do set.seed again. Then I run the command. You see, I have the same result. So that's the essence of using this set.seed function. So moving forward, now here in this case, using the duplicated function. The duplicated function, what it does is that it checks for duplicates in a particular column. Let's say you're using a data frame, for example. So you can say, okay, where do you have duplicates in this column? So it starts from the first value. The first value is going to be false because I'm just checking the first value. So obviously, it's not going to be a duplicate. But there's possibility that the second value might be the previous value. So I'll check again. Is this guy the same as the previous value? If no, false. It checks again. Is this guy the same thing as what I've seen before? Then if it's there, then true. So you can see one is true because one has occurred before. Then if you look at this one here, it's also true. So that's the essence of using duplicated function, and you can use it to subset your data set. So you can use it to subset your data set. So let's take for instance, let me create a vector. Say okay, BEC. Okay, let me use this one. So 3, and then put 4 and 4. Okay, let me now use the function duplicated. So duplicated BEC. You can see I have true for the last 3 here because 3 has occurred before, 4 has occurred before, 4 has occurred before. Now, if I want to get the exact value, I can use something like okay, BEC. I can do something like okay, BEC in brackets, in square brackets. So let me say duplicated BEC. Then I run this command. You can see now this command helped me to get the vector so that has duplicate. So it just gave me the one that is true. So it used the logical result that this guy returns to subset this guy. So anywhere that it is true, the resulting value is returned. So it is true for this last grade. That's why you have 3 for you. The can use it to subset it. So it's very necessary. So moving forward, now here it said to find and remove rows with missing data, you can use something like na.omit command, as you can see here. But there's a function called complete.cases. So complete.cases is a logical vector with the value true for rows that are complete and false for rows that have some null values. So let's say we want to create a vector that has null values, for instance. So let's say this guy has no value. So let me put a null value here, NA. So this guy has no value. Now let me say NA. So if I call VEC for you, let me first of all call VEC for you. If I call VEC, that's what it's like. You can see I have no value NA. Now, if I say NA.omit of VEC, then this guy just return all the values in VEC without the null value. You can see here, it returns everything without the null value. Now, if I use complete.cases to complete cases of VEC, you can see it gave me true for the value that are not null and false for the value that are null. I can also use this to subset VEC. So I'll say VEC in square brackets, then I'll put complete.cases of VEC inside it like this. This is going to give me VEC, the vectors that are not null. So it's going to do the same thing as na.omit. So if I should run this, you can see it returns the values of in VEC that are not null. Okay. So moving forward, it said consider you have a data set sales data which has two columns. The names of the columns are date and sales, respectively. Which of the following is the correct function to remove rows with missing data from data sets, sales data? So use any dot commit into bracket. You can see don't pick this guy. See this one any dot commit, but any dot commit into bracket. That's how you write the function. So adding calculated fields. So adding calculated fields. So I can do calculations on, say, I can do it on vectors, I can do it on matrices. So let's take, for instance, I have the matrix BEC. So BEC. So if I call BEC, you can see it has no values. Now, if I do BEC times 2, if I do BEC times 2, this is going to multiply every element in the vector by 2, as you can see. But the n is not going to change because 2 times the number is still a no value. So the same way you can do it in vectors, can do it in matrices, can do it in data frames. So let's say I want to create a matrix. I think I've already created a matrix before up here. I think I already did. Okay, this is a matrix. So let me call it M80. M80. And I'll come down here to call M80. So let me call M80. M80. So this is the matrix. The matrix of 4 rows and 5 columns. So if I want to multiply everything by 3, I can do times 3. And I have this result. You can see all of this multiplied by 3, all of this. So it's multiplied everything inside by 3. So the same way I can do calculation with all of this, I can do it data frame. So I have a data frame called iris, so that is here, it is available here. So this one I've already added one calculated fees called ratio. So but let me call the data set again so that I won't have that part. Data iris. Okay, so let me call my iris now. You can see now I have this guy. So you can use the add function to see just the best 6 rows. So I have this. So if I want to do, okay, this guy times this guy. Now, for example, if I want to just call this particular column, I can just use the ampersand sign since I'm just interested in that column. Iris ampersand. It gives you an option to say separ length. And one this is going to give you a vector of the values in that particular column. So if I want to call the iris ampersand, you want to call the separ width column, I can say iris ampersand separ width, and run it, give you the vector. So if I want to do this divided by this, I can say, if I just copy and paste and put slash using the division sign and put this. So the result is what you have here. I can assign this to a new variable, say x, and that is exactly what they did here. So it's a vector. But if you want it to be added to the data frame, you can use the within function to do that, or subsetting format to do that. So I'm going to say how to do that. Now, here we are doing width, the width function. So the width function, this is the advantage it has. So for example, as I have here, that I did this divided by this, that I have to do ampersand this slash I ampersand this. I can just say, okay, with the iris data, so just English, with the iris data, do separ dot length divided by separ dot width without having me to reference the iris data set in that regard. So I can actually do this. If I should do this, you can see it's giving the same result of this guy. So if you want to be sure whether it's the same result, you can use the word identical. Let's see whether they're going to work out with what we want to do this for. I will copy this particular operation, then paste, then put a comma and compare this guy. So you can see it is true, telling me that this operation is the same thing as this operation here. So that's another way to perform operations on maybe data frame, especially. And yeah, so using their column name, their row name or your column name. So we also have what we call the within function. So the within function is that, okay, suppose I have a data set iris and I want to create a new column performing one operation, then using the say separate length over separate width, and I want to assign to a particular object, and that is going to form a new column in the data set. I can use a within function. So there are two ways you can do that. So I'll show you how to do that. So I'll say, okay, iris is now within, then I'll say iris. So I'll specify the data I'm using, then I'll say I'll call the column name. So the column name, the new column name I want it to be say ratio is now equals to where is it again? This divided by this. Ratio is now equals to this operation. So as you can see here, so within iris ratio is equals to this by this. So if I should apply that operation, it's going to create a new column ratio in the iris dataset, and the ratio is going to be this column divided by this column. So let's run that. Okay, I think we have something is missing. I said error in about. So let's change this one to. Okay. Let's run it in this. So, all right, it's evaluated successfully. So let me see head of iris. You can see the new column has been added, called ratio, in the iris dataset. Okay, let's say you don't know the within function and you want to actually do this. So I want to remove the ratio column. So the ratio column is in the index 6. I think 1, 2, 3, 4, 5, 6. So I just say remove the 6th column. So -6. Sorry, I have to put iris is equal to this. So my iris now is equal to iris excluding the 6th column. So okay, I've done that. Let's check the head of iris. You can see the ratio column is no longer there. Now, so let's say we want to include the ratio column another way. So I think I should be able to do this using this command. I'll say iris give me corresponding to all the rows, and if
sorry, Emmanuel.
Yep.
So for within is to include a column, right?
Yes.
I mean to add column.
Yes. So you can inside.
So does it matter if the rows are of the same length or not?
For a data frame, the rows will be of the same length for a data frame.
Okay, so just to point that out, in case the rows are not of the same, same length.
Yeah. So for for data, for spreadsheet kind of data, the rows of the column have to be the same.
So it's possible, like, okay, let's say the rows is not up to, let's say for the iris table itself, there were about 1,000 rows there for each of the columns, and then you want to add the new column to it, and that new column has maybe 1,030.
Okay.
Or it is less, maybe 970.
Okay.
So is it that you have to delete or you have to fill other spaces with null, or what? How do you fix that?
So if you have a row that you want to append to a data frame, so like this data frame now, as it is, so if you have a column that you want to append to this guy, so it means that the column you want to append to this guy must correspond to these corresponding values. Like they must have the same attributes. It's not like they are records now, so they are records. So in that case, it's not that you just have to do you just append it. So you can do what you call a join. So it's like we want to do maybe inner join or left join, but having to append so it's like you are saying you want to create a vector and append it to this guy. So if they don't have the same if they don't have the same length, so let's see what is going to happen. Let's say we want to append the vector to it. So let's say VEC. This VEC has how many lengths? This is 9 lengths. And this guy, this iris data set has 150 rows. So you can do something like this to append that guy to it. I will now say iris or let's use the within operation. So let me use this within operator and say, okay, iris, I will now say ratio is now equals to VEC. So let's do this. So you can see here, it says replacement elements, one has 9 rows, need what? 150 rows. So it means that there's an error. You can't append vector that does not have the same length as the what? As the data frame. Do you understand? Are you seeing this?
Okay, so in a case where there are missing data and competing data points, like NA, where you have NAs for them, can't NA fill up those spaces?
So if you want NA to fill up those spaces, you can just complete the vector that you want to append with NAs so that it can match up with the original data frame. So if I want to do that, I can say VEC is now equals to combined VEC. Since I know that it has 9 rows, and I want all of the rest of the rows to be NA, I will now say repeat NA 141 times. So 141 NA with the initial 9 values that I have is going to complete 150 values. So if I should run this now.
No, it's not. That's not what I was saying. You know, in some data points, they are not always according. Like it's not like, okay, the first 10 rows are filled and then the next 90 rows are empty. You get? What if they are random rows that don't have data points?
So like if you say like in the iris data set, for example, now maybe if I should call the iris data set like head of iris, and some of the entries in this column, okay, if they are empty or they have NA value, so
yes, like if that is the case for the new data points you are the new columns you are trying to append to it.
If the empty rows and the normal value that it has, if it completes 150, it's going to append it. It doesn't mean that it has to have real values, but if the length is 150, it's going to append it to the data. It doesn't matter.
I just wish we can clarify this thing.
What you are saying that if the column you want to add to this guy, if the rows complete 150, whether it's empty value, whether it's no values, since the rows has 150 rows, and it can be to append it to this particular data set.
Yes.
If it does not have the same length, you won't be able to append it.
Okay. All right, let's go on. I think we will find out.
So moving on to the next guy here, say creating a subgroup of bins of data. So peradventure, I want to create I have a particular data set like the separ.length, and I want to group them into maybe 3 equal groups. So what we are saying in essence is that let's look at the range of the separ.length data set. So the range of iris and separ.length column, for example. So if I should run this one is saying that the minimum value in this column is this, and the maximum value is this guy. So if I want to break them into buckets, say, okay, give maybe 3 equal buckets. So maybe values from this range to this range should fall here, values from this range to this range, and cut values from this range to this range. So I can use the cut function to do that. So I can use the cut function to do that. So let's see whether, so as you can see here, this one is saying that cut a particular column called first into 3 places, include the lowest equals to true. So for this particular case, the iris data set is separate the length column, for example. So I can say cut this guy maybe into 3 places. Then this one equals to true. I can use capital letter true in full or capital letter T. So you can see here, I have different bins. So this is the first interval, 4.3 to 5.5. Then we have 5.5 to 6.7. Then 6.7 to 7.9. So it has divided it into 3 equal intervals. So all of these represents where a particular value in that column falls in. So this one is saying that the first value in this particular column falls in this interval, the second falls in this interval. So I should be able to make a plot of this. This isn't just this interval. So I'll just have 3 bars in my histogram instead of having to have them packed up in some kind of way. So I can also use labels to. So let's say you have the salary column, for example. I want to cut it into 3 equal parts. So the first part, which is the starting from the lowest, can say okay, low salary. Then the one in the middle can say medium salary, and the one in the higher part of it of the interval will be high salary. So then I should be able to plot that histogram in that regard. So as you can see here, this one we added labels to it. Say so for these 3 intervals, give me low, mid, high. So I labeled it in this way. So instead of me having this interval like this, so this one, since this one is one that falls in the lowest part, I can label it low. So instead of me to be showing this guy, it's going to show low. So let me include labels for this guy. So labels. Label is equals to say low, say medium, I don't know, medium. So let me just say med, then say high. So if I should run this command, so what then? I use argument labels. What's happened? What's happened? What's happened? Oh, sorry, I was using the wrong function. Sorry, I'm supposed to type it in. So let me just copy this again. So if I run this now, so instead of me having the intervals, I have the labels now. So if I want to see a summary of these things, I can use the table function. So I can say x is equal to this. So let me assign x to be this operation that I just performed. So if I want to see it in a more appropriate way, say I use this table x. So this is going to summarize what I have. So it means 59 records falls into the low category, 71 falls in the medium, then 20 falls in the high category. So the table function helps to like summarize the data in a way. So I can say, okay, if I say plots, so if I want to plot this guy, table, let me see. Yes, let me see what this one goes with. So this is not the way I wanted to plot it. Anyways, let me see. Let me see. What's like this one? I don't really like to plot in this area. I just like using the frame, so I'll be able to see it very well. The Windows function. So let me say Windows 9,7. So this what happened? Why is it? Oh, I cannot. Maybe I can't use it here. Sorry, I might not be able to use it in this. So if I'm doing this on local, I'll be able to do that. So you can see they even use table of X here, which helps you summarize what you have. They didn't show it. They didn't show the result. So I think with what I did earlier, we are able to see the result of the table function. Okay. So here we talked about combining and merging data sets. So this is where we are going to talk about maybe row bind, column bind, then the joining of the data frames like your inner join, outer join, like left outer, right outer, full outer join. So okay. Now let's see how we can go about doing that. Let me even see this guy. That is this. Then can I call this guy since it's okay? Yeah. Yeah. Okay. Let me see what this guy is. If I should do this with just this guy, let's see what we can bring up. Oh, no. This is not the way I wanted to bring it. What is this guy brought up? Is that is that. So let me see what this one got. Okay. One. I just want to say, okay, this is all the rows. So let me say, I just want all the rows. Okay. Okay. Okay, fine. So moving forward, I think I already explained the concept of column bind. So I think let me come up here. Yeah. So here I created a vector A, B, and vector C. I think A, B, and C is different in entirely. So let me call A, B. A, B here, I think is a matrix. So it's a vector, as you can see here, 10, 15, 20, 25. So let me call C. C is a matrix. Can you see this? So now, let's say I want to join this vector AB, which is this guy, side by side with this guy, that is column wise. So I'm going to use the word C bind. So basically using the word C bind is going to add 10, 15, 20, 25 to this particular position. So let me run this now. As you can see, 10, 15, 20, 25 is being added here because I called AB first. That's why it's added to this first position. But when you put AB here, to the right hand side, it's going to fall here. So let me rearrange it. So, comma AB, you can see 10, 15, 25 has been added to this place. So most of the time, you can use this guy when you have several vectors and you want to like append it together. And you want to make it to form a data frame in a way. You can actually do that. So also using row bind is like you want to append it row wise, that is to the bottom, from the bottom. So if I want to append C and AB row wise, I'll use the function rbind. So if I say row bind C is this matrix, then row bind AB is going to just join it from the bottom here. But note, AB has 4 entries. Now, this on a row wise case, it has like how many entries? 1, 2, 3, 4, 5 by each row. So if you want to append 4 values on this guy, it's not going to complain if you're using the out bind or C bind, but it's going to give you a warning that something went wrong. So let me run this. As you can see, it gave you a warning. Say number of columns of result is not a multiple of vector length. So what just happened? You can see what happened is that 10, 15, 20, 25. When it got here, it now started from the beginning again, 10, to replace this guy. So apparently if you didn't give a warning, you won't know what is actually going wrong. But it's not going to give you an error, but this is actually what it's going to do in the background. So that for you to know what you are doing. So data frame won't allow this. I won't fill in with no value. So it will just give you an error that it can't do that operation. But this is going to give you a warning, it's going to perform the operation. But if it does not match up with the length, it restarts again to fill in those spaces in that regard. So that is row bind and C bind for you. Now the merge function is the one that is used to do the join. Now we have the natural joins like the inner join, the left join, the right join, the full join, so using the natural join, you're going to like the inner join, you're going to specify your x, that the guy at the left, the guy at the right, which is your y. Now, if the two columns that is used to join these two maybe data frame in this case, they are not they don't have the same naming convention. You are going to specify the naming of the one at the x, the naming of the guy at the right. So okay, you are joining using this column, and when this column equals this column, that's the way you do it in SQL. So whenever this guy is equal to this guy, it's going to join these two guys together. But in case whereby there are two common columns that you can use to join, you can just use this condition, say bar is equal to this. So you understand that you are joining using this column. But sometimes ourselves automatically determines your column. You don't specify this guy, and the columns that join these two together are common. They have the same naming convention. I can just automatically join it for you. But you have to be careful because some data frames might have two columns that have match. So in that case, I might be confused, and you have to specify what column you are using to join exactly. So that's the essence of using this bar. Now, so this is going to perform an inner join for you naturally. This is going to perform a left join. You can say I specify the column I'm using to join. Then I said all dot x is equal to true. That means select all the guy in the left and use it to match the guy in the right, left join. Then for right join, select all the guy in the right. That's why I say all dot y is true. Select all the guy here and use to match the guy in your left. Then full join, all is equal to true. Select everything to your right and to your left, and join using what the department ID. In case probably what you are using to join is the department ID. I hope this is clear. I hope this is clear. But let me see whether I can find a data set that I can use to perform this. Yeah, I have employees table here. Do I have department table? For example, I don't. I'll use that to demonstrate. Can I get to? Hello, caller, are you there? Hello. Okay, so that's the concept of join. That's the concept of join. I really would have loved to demonstrate this here. So let's look at this knowledge check. Suppose you have two data sets A and B, Dataset A has the following data 1 to 4. Dataset B has the following data 5, 6, 7, 8. Using the merge function, combine the data from both sets into dataset C. Okay, so I said using the merge function, combine the data from both data sets into a dataset C. Okay, let's try this out. So if I have, say, A to be 1 to 4, then I have B to be 5 to 8. Okay, as you see, is merge. So let's use A, comma B, for example. So let's do this. Now, if I call C, this is what I have. So this automatically does a cross join for you. So this does a cross join for you, as you can see. Yeah, I don't think I talk about cross join. So talking about cross join, you don't specify the column you are using to join in this case. So it automatically does a cross join for you, as you can see in this case. You can see C. So it just does 1 is being matched to 5. So what it does, 1 to 4 is matched to 5. 1 to 4 is matched to 6, 7, 8. So this data is matched with the first element in this data, which is 5. Then it goes to this data, matches to the second, so it gets to 8, as you can see here. So it does a cross join for you. So, but then let me say I want to do a full join. I can say all is equal to true. So let's see this guy. Let's see. So as you can see, it still does this for you in this case. So because you don't really have what you can use to join it, so it's definitely going to do everything you have in A and join with everything you have in B. And the reason why I'm having this is that there is no specific column you are using to join it. So that's why you have this also. So okay, moving forward, we have this guy. So let's see whether we have this particular data set. The merge function is used to combine data fields as follows. It's a merge to find the intersection of data, merge code state and large state. And we go like this. I have this guy in my environment picture. I don't think states don't exist. It says an inbuilt data set, but I don't know whether it is here. So let me check data into bracket. Let's see, I'm going to find it. What is state.xlist is not here. Let me see. Okay, I don't have that data set in this R, so you won't be able to. I would love to do this, but I don't think I have this data set here. I don't have it. So let's just move on. So here you have a data set called state.sound7. Then it was separated to two data sets called code state and last state. It's separated it in one way. So this is going to do the natural join for you, obviously. So So it's a command. This command is to create a data frame that consists of code as well as large state. So it's just find the intersection, which is what Energon does for you. So moving on to the next slide. So here, so working with lookup tables. In case a full merge is not required, a lookup table can be used as follows. So if you are not doing a full local join, you can say, okay, give me where this guy matches this guy. So match here gives you the index whereby there is a match between the two columns. Welcome to the So can you hear me?
I'm sending your report to you.
Hello, Chide.
Yes.
So this match gives you the index of where there is a correlation between this code state and large state data set. So if you are using the name column in this code state data frame and the name column in this large state data set, probably you want to join these two states based on their name. This can give you where the name here matches with the name here. So as you can see in this function, it said column row 5, row 1, 4, 5, 6 has match, but all of this does not have a match. And you can so here it said talking about sorting and ordering data sets. So parameter I want to create a data frame with region in state.region. So the region, so I want to create a data frame region, state region and include states.x77 also. So you have the some states. So here I want to call the first 10 rows corresponding to the 3 columns, the first 3 columns. So this is going to do that for you. So this is how we do that. This is what we're talking about. So let's say this iris data set. I need the first 5 rows. I can do this, comma, then I specify the columns I need. If I want column 2 and 3, I can do this. So if I do this, you can see I have 1, 2, 3, 4, 5 rows corresponding to second and third column. Now, if peradventure you need just the first and third column, you won't be able to do something like 1,3. So you have to put this in a combine function. Say I want the first and the third column, and I want this. So I have the first 5 rows corresponding to the first and the third column. So you can do this. So if they follow each other, then you can use this vector form to call them. So the first 5 rows. But if you want to call it uniquely, so you want to call it in a distinctive manner that maybe they don't follow a particular order, then you can use the combine function to concatenate those particular index together. So, but here you're calling the first 10 rows corresponding to the first 3 columns. So let's see how we can sort our data. So we can use the sort function, for example. So let's see how that works out. So coming here. So as you can see, this guy is not sorted. It's not sorted. So suppose you want to sort this guy. So let's say I want to sort. If I say sort this guy now, guess what is going to bring up? So sort into bracket this guy. Guess what's going to happen? So you have an error, all the 5 columns, blah blah blah. So you cannot sort a data frame in that regard. So let's say I want to sort iris, then I want to sort the first column, which is separate on length. So let's go to that. So as you can see here, it automatically sorts this data in increasing order. So what if I should do something like this? Which this guy. So what if I do something like this? Yeah. So which is not a logical operator, so I can do this. So what the which function gives you the position of the row position in a particular data frame in that regard. So here I'll be able to sort the sepal dot length. So if I want to sort it in descending order, then inside this guy I can put parameter called decreasing equals to true. So this is going to do it in the descending order. But you can see this start from the largest to the lowest. Same thing they did here. Now we can use this command to like this other command. So this command shows the order of the elements in the data. So this command shows the order of the elements in the data. So let's say I want to sort. So let's say for this guy now, I want to sort this guy based on the order of sepal dot length. So the trick I can do here is that I'll say iris, then in square bracket, then I'm going to say sort, so not sort, order. So I put a comma. So in the column part, I'll now say order. So I'm into order iris. So I want to generate the iris data set based on the order of sepal dot length. So let's do this. So let's check our data set. So you can see that the iris data set has been called depending on the arrangement of sepal dot length in the order of this first column, which is sepal dot length, as what I did here. So I said I want all the columns. That's why I didn't put anything after this bracket. So this guy gave me the results based on the ordering of this first column, which is sepal dot length. You can see it started from row 14, row 9, because it's doing it in ascending order, so they might not follow the same order. So you can see it started from the smallest, then following. So probably I want to sort it, this guy. I want to sort the iris data set based on this particular column, but in descending order. Then inside this place, I'll put the decreasing function. Say decreasing, as you can see on my screen here. So let me show you. Say decreasing equals to true. So I will do that here and also say decreasing equals true. I can put capital T or type true in capital letter. So any way you do it. So let's see. You can see it's in decreasing order now. So you can see it start from the largest to the lowest. So that's the way you can sort in R data frame matrix. So let's say you have a vector, for example. So this vector has n is. I want to sort this guy. I need the sort function directly to sort BEC. So it gives you the order. But you didn't return the NA. So it didn't return the NA. So let me say NA dot RM. I don't know whether I can use this with the sort function. Equals false. I don't know whether I can use that. I can't use it. So this guy does not include the NA. So it just give you the values, the valid number elements in the vector, and just substitute for you in ascending order. But what is in descending order, you have to specify this parameter. All right. So moving on. I said, which of the following is the correct syntax to sort the element of data set X in decreasing order? So you use the order function, yes, specify decreasing equals to true, which is your right answer. So traversing data with the apply function. Now it's this function that's very essential working with data frames, working with vectors, arrays, lists, and all of that. So they are very, very essential. So how do we do that? Say, how provide the apply family of functions for traversing the data? The output of apply function depends on the data structure being traversed. So for array or matrix, so the apply function traverses either the rows or columns of a matrix, applies a function to each resulting vector, and returns a vector to summarize itself. For this, we use the lapply function, and traverse a list. It applies a function to each element and returns a list of the results. Sometimes it's supposed to simplify the results list into a matrix of vector. We also have the sapply. I think we're going to talk about that. So these are the arguments that the apply function can take. It takes the data, can be an array, can be matrix, each. You can have a data frame with the apply function. So specify the margin. Do you want it to do it row wise or column wise? So row wise, you specify margin to be 1 or 2 if it's column wise. Then you tell the function you want it to apply on it. Then this is just like it can take extra parameter depending. So if the function requires any additional arguments, then you can be added in this regard. So before we move on, let's see how we can use that. You can see S applied to here. So let's work with iris dataset, for example. So let's say apply on iris, but okay, then iris dataset has a categorical column. So let's say I want to apply it on column. So this two is specifying the margin actually column wise, and I want you to find the mean of those columns. So it might give me a warning because the last column in the iris dataset is a categorical variables. So you cannot find the mean or man just an error. So you can see it gave me an error because there's a particular column there that does not have that's categorical. So that's why you're having this NA. So let me say I want to exclude that particular column. So it's the 5th column. Let me exclude it. So this is what you have. So you have the mean of separate length is this, the mean of separate width is this, the mean of beta length is this, the mean of beta width is this. Also, you can do this with the matrix. As you can do it with data frames, you can do it with matrix. So let's say there's a matrix M80. I want to find the sum. I can use the apply function and say apply on matrix. Row wise, I want to see row wise now. Then give me the sum. So it's going to apply on this row, give the sum for this and this and this. Let me run it. So same the sum this row is 45. The sum in this row is 50. The sum in this row is 55, and the sum in this row is 60. So that is the usefulness of the apply function. We also have L apply, which you can use for lists. I don't know whether there's a particular list I created here before. I think I've created one list before called. I think I created one list in this session. Why can't I find my list? Let me check. Sure. See, there's stuff. Okay, yeah. So I don't know. I think there's. Let me check whether my list. I don't see there's a function that I have created. So let me say my list is now. Let me create a new variable. Say my list is now equals to list into bracket my matrix and the data frame. So with iris. So this is going to contain iris and a matrix. So let me call my list, for example. So my list. So this is what you have. You have the vector, you have the data frame. So you're talking about L apply function. So we also have T apply. The T apply function can be used to create tabular sums of data. So the function takes 3 arguments. The X is equals to the vector, the index, which equals to a factor or list of factors, the function. So for example, let me apply the T apply function. Where can I Okay. So apparently you can use something like this. So let's say T apply. First of all, let me use the table function so you can see this. So table, so let me use the table of the categorical variable in iris, which is the species. So you can see what you have. It's saying that Setosa has 50 entries, this one has 50, this one has 50. Okay, let's use the T apply function. T apply. And let's do that same thing. Let's see what we have here. So it said the argument index is missing. So the argument index is missing. When they talk about index, it refers to the factor or list of factors. So, and the function. So let me say, I think there's a function called count. Count. There's something count. Okay. Let's say I want to say, okay, this is going to have Setosa, university, color, and Virginica. Okay, let's see what happens. It said arguments must have same length. Okay, yeah. I don't just okay, yes. So let me do it with let me do it with separate length data set. So let me just do it this way. So let's say I want to do something like this. And I say iris. So the same way I can do something like what did I do with the data frame here? Okay, I did this with apply function. So let's say iris ampersand spreadsheet. Then I specify okay. So let me call this one to be iris ampersand separate length. Then comma iris ampersand spreadsheet. Then I want to apply the mean. So this is what are we going to get? Let's see. So here is saying that give me the mean of paper length as per each species. So that's the advantage of using the apply function. So I want the average of species as regards to paper length. So for each species, give me the average of their paper length. So this is the use of T apply function. Now we also have S apply. Let me see. So there's a various way you can use the apply function, and these are the various way you can write the parameters in the function. So let's say the introduction to formula interface. So the formula interface now allows to precisely specify the columns to be used when fitting a model as well as the behavior of the model. So it's important to keep in mind that the formula notation refers to statistical formula as opposed to mathematical formula. So for example, the formula operator plus means to include a column not mathematically add. So this is saying, okay, model Y depending on X, so the response and independent variable, response and explanatory variable. So this one is saying viewed based on A and B. This one is based on A but exclude B and stuff like that. So for example, if I want to use the table command now, for example, I won't be doing this with. So let's say I want to do something like this. Table. I really don't know. I don't have an illustration. If we talk about it later, sure. I don't want to waste much of time because I don't really have much time. So I think in maybe in the next slide, we're going to see how this actually works. So also putting data into shape. To utilize data to the fullest, now the data can be reshaped in order to perform the best analysis. So you can use it into converting into long or wide format. So when converting data between long and wide formats, it's important to be able to distinguish identifiable variables from measured variables. So we are going to see how this works out in the next slide. We actually go to use the F table function to do this. So now is that this reshape library is what we are going to be using. So base R as a function called reshape works fine for reshaping continuous data. So we can install the packages. So install the packages in shape. So if you don't have it installed, then you can load it inside the R environment to use it. So let's see how this works out. Okay, this is to go from wide format to long format, not function. They didn't talk about this. That was very sad. That was very sad. That's very sad. Function. So I think we just have to read about those functions. I think we have the DASCA and the melt function. So, so the melt function is to, you can see here. So I said you want to convert from. I said you have the data set is in wide format. I want to convert it to long. So convert from wide to long format to use the melt function. But converting to the wide format to use dcast. That will be a function for dcast to do that. But I don't have how that function how data will go. I don't have any data set. So if you look into your material, you're going to see how that actually looks like. So it's very basic. So this is the summary of what we have talked about today, talking about matrices, talking about vectors, lists, and data frame. And the way to subset is ampersand sign, the dollar sign, double square brackets. So let me go back. I think I need to go about that. So I have a list that I created called my list. So you can see here, if I want to call the first guy, the first element, this is the matrix, double square bracket, then specify one. So you can see it gave me the first guy in the list, which is the matrix. But if I want to see the second guy, I'll just change this from 1 to 2. So the second element in that guy is the data frame, as you can see here. So that's where you can subset your data. So let's say I want to call just maybe few things from this guy, and I should be able to do something like this. If you give me okay, I just need the first 3 rows, for example, as you can see here, give me the first 3 rows of the data frame I have in that list. So you can subset inside another subset. So you call the second element then, but I just need the first 3 rows in that element, because I need the data frame so I can do this. So you just need, you guys don't need a lot of practice. So we talked about duplicated function, we talked about compute cases, any.omit, within and with function. I talked about the R bind, the colon bind, as a C bind, talked about the merge for you to perform joins in R. Yeah, we have natural full join, left join, right join. Also have cross join. In that case, you're not going to, you don't have a bar, you have a column that you are using to merge it two tables together. In that scenario, you're going to have a cross join. You can also sort using the sort or order function. You can use the match function to see, okay, where 2 particular tables have a match. you can use to get the index of them. You can use the apply, S apply, T apply. I think we have to read about all of that. So apparently we are done with this particular session. So in the next module, we are done with this module. In the next module, we have data analysis using R. So I will quickly try to let's see. I can talk a little about this particular session. It's using functions and packages in R. I know I won't be able to finish today, but let me just see how far we can go. So using functions and packages in R. So in this session, we're talking about how to develop scripts and functions in R, using arguments with functions, explain the function environments in R, methods with functions in R, install, load, and unload packages for R. Okay. Firstly, so these are the capabilities of R. So these are the great things you can do with R. Effective data handling and manipulation components. I can expect that it's very easy to work with R when it comes to data manipulation. Advanced visualization capabilities, very fantastic with that. Operators for calculations and arrays and other types of other data, tools specific to a wide variety of data analysis, support for functions, and scripts for developing new methods. So scripting is just have to write something in this environment and save it as .r and probably just want to source it now. So scripting is just like, okay, I have a particular process I want to run, maybe follow a particular process. So I'll write everything step by step, top down. So and I want to see a particular result, I can use the print function. So if I want to run that particular script, I don't need to open it and say highlight everything I want, or I just need to just source that script there. Just I can use the source function or the source button here, or use the source function and specify the script I want to run. So, but let's see how this works out. You can also turn your script to a function. You can move from script to function. So you have already used scripts by using a source function. Similarly, you can also use function. So a function has two major advantages over script. It can work with variable inputs, so you can use it with different data. So script is that anything you write is being specific to a particular data, maybe you're working with something. So it just works with particular data. So function is that, oh, it's going to be dynamic. I can put, okay, I created a function to maybe find average in columns, for example. The columns of the data frame. So in that case, that function can take in any kind of data. So I can come there and say, okay, put XYZ data there. It's going to find that result. Okay, I don't find for XYZ, I don't find for ABC data. I'll put ABC there. I'll use the function, still performs the same. It was script. Unless I open the script, then I will edit again and have to put the name of the new data I want to use, but it's not that with function. So it works with variable input, so you can use it with different data. It returns the output as an object, so you can work with the result of that function. So I can assign a variable to the output of that function and continue working with it. Now, creating a script. So you can create a script in any of the text editors. You can do it in the RStudio editor using Notepad, Microsoft Word, or Notepad, and save it at .r code extension and just call it in the R file. That's going to be fine. You can use that the source function, or you can use the source button in your RStudio. As you can see here, this is using the source function to source the script called sample.r. Then you can use the source function to source by task. All right. Now, so let's create a script that represents fractional numbers as percentages rounded to 1 decimal digit. So how do we do that? We open a new script in the editor. So I'll go to File, I'll click on New File, then File, New File. Then I'll go to our script. This is going to open a new script code. You can use this shortcut, Ctrl+Shift+N. So after I've done that, it's going to give you an empty script that you can type whatever thing you want to type. So in this case, I created a vector X having these fractional numbers. And I said, okay, percent is now equals to round x times 100. So multiply every of x times 100, but round it up to first just one decimal place. So, and I say result is now equals to paste the result of this percent and add the percentage sign to it and separate it with an empty space, an empty string, and print this guy. So that's what is inside my file. Then I'm going to save it. After I've written this, I'm going to save it. So save. So after I've saved it, save the script as a script file. For example, paste %.r. Maybe I save that as file. I can call the script on the console by using this source function. So this is source, then put in quotes the name of the script I want to run. If I should run this time, then I have this result. So you just perform this operation given this particular data, and you can see say print result. So the result it's printed is what we have here. Now that is scripted for you. Now to convert the given script into a function, you need to do the following. So you define the function with a name so that it becomes easier to call the function. So you're going to say, okay, paste percent. This is that's the name of the function. It's now equals to function. You start building it, and then you say, okay, you can use the return statement that acts as a validate of the function. That is, what do you need it to do at the end of the whole body of the function? We're going to see it in the next slide. Okay, so this return function provides the final result of the function, which is returned to your workspace. So the function should be followed by parentheses that act as a conjugate for the function. Between the parentheses, you're going to put the argument for the function. You can put as many arguments as possible depending on what you want to create. But let's see what happens in this step. Now, I'm creating an add percent function. So this is how I create the function. So add percent, that's the name of the function I want to create. And I say is now equals to function into brackets. Then inside the function, I'll put a parameter. So I want this guy to take a particular variable called x. Okay, fine. Then I'm going to open a curly bracket like this. You can see it's going to have a beginning, then you're going to have an end here. Inside the bracket is going to be the operation I want it to do. So inside the bracket, I have percent should now be equals to round this particular x I'm providing, multiply it by 100, then return in one decimal place. So just round it up to one decimal place. Then the result is paste percent, that is this value, and add the percentage sign to it, separate it by an empty string, then return this particular guide. So like how your print works in your source, in your scripting as it is here. So as it is here. So this is dynamic. This is dynamic. So I've finished everything here. So it's going to, first of all, when I call this function, it's going to do this, then return this particular thing, which is this last time. So you're going to see that. Now, you can see here, your add percent function takes one parameter. So this parameter can be your x here, can be a vector of fractions. So let's see how it works out. So I've created the function. Now, you can use the ls command to see the object you have created. You can see the add percent function has appeared because you have created that function. So let's see how we make use of that function in the next slide. So I created a variable called new numbers, which are fractions. So I want to use the add percent function on this vector. I just say add percent, then I put the vector inside. If I should run this line, this is the output I get. So what it does is it performs the body of this function using that vector I created, that is this new number. What it does is that it multiplies the new numbers by 100, convert it to one decimal places, and add percentage sign to it, and return what you have. And that's why I have this guy. I hope I am making sense at all. Hello. Hello? Okay, so apparently this is what I'm talking about. Let me log in. So I want to create a function to add percent, for example. Okay. This is now equals to say okay, function. How do I create the function? You use the function keyword into brackets. Then inside this bracket, you specify the parameter it's going to take. So it's going to take a particular s, then I put a square curly bracket like this. You can see it's already give you that this guy is a function. You can see. So it's going to take a parameter called x. So I'll put inside the body what I want this guy to do for me. So what I want this guy to do, say I want to say percent is now equal to round x. So do x times 100 for me and add it to what? One decimal place. Then I will now say result is now equals to paste. So I want you to paste percent for me. And I want you to add the percentage sign to it, but separate by an empty string. Okay, so after this, I want you to return the result so that I can see the output in the console. Return result. So all I just is to now highlight everything and run. So the add percent function has been created. So let's say I want to use the add percent function on a vector of decimal. So C into bracket 0.01314 and 0.12315 and 1.012. But you want this time. What happened? Okay, it's a comma to put. Comma. If I want this guy, you can see what I have here. So it converted everything to percentage and put the percentage sign with it. So that okay, this is 3.1%, this is 24.1%, this is 101.2%. So we did this guy multiply by 100, convert to one decimal place, then paste. So the result is paste percent, that is the value I have after I multiply by 100 and convert it to one decimal place, and join the percentage sign with it. I want it to separate by empty string. Then return what I have. This is this guy, return the result. That's why you have this. All right. So moving forward, so using the function as object. So as I have created add percent, I can add this another thing entirely. So let me see what this one's talking about exactly. So as you can see now, okay, suppose they didn't show this part. So apparently this is what they are talking about. So this add percent function that I've created, I can say p paste is now equal to add percent. So if I say p paste is equal to add percent, it means that what add percent is now doing, p paste will now be able to do it. So if I want to do the same, so I say p paste into, I want it to operate on this vector. So I just put it inside here, then I run. You can see that p paste did exactly what add percent just did. So if I copy paste, for example, like this, you can see this is what I assigned as p paste. This is the function. So p paste is exactly what add percent. So that's what they talk about using function as object. So ways of reducing number of lines. So what are they trying to say is that is dropping the values or returning values by default. I can reduce the number of lines I use writing my function. Let's see the next slide. So here, instead of me to say, okay, look at the return statement is optional by default. I will always return the value of the last line of code in the function. So instead of me to say results equals to this, so what am I trying to say next? So instead of me to say result is equals to this guy, and then say return result, I can exclude this part. But if I don't need to assign results, I just want to see this operation. Then I don't need to assign this to result again. I'll just say paste this particular thing. So if I just then I run this add percent, it's going to paste the result from automatically, as you can see here. So that's quite more effective since it performs the same thing as having to assign to result, then say return result again. So I don't think that is necessary. So also I can drop braces. This braces there's where I can drop braces once kind of function, but I actually like using the braces. It makes your function more readable, and you are going to understand actually via what you are writing. It just makes more sense using the braces. But if you look here, this is making it more dynamic in a way. So you are trying to make your function more dynamic. So here I'm saying that okay, I'm creating an add percent function, and I say function is equal to function is a function of a particular parameter, say x. Then I will say if I'm using a conditional statement here. So if that particular x is numeric, so if it is, you say not is dot numeric x, return null. What I'm trying to say is that if it checks that this guy is not numeric, this particular vector I'm passing, this particular parameter, if it's not numeric, return null. But if not, it's going to do this. I'll just say paste this guy. So here it checks whether x is numeric or not. So if it is not numeric, then it returns null as a result because I won't be able to perform operations on it. So here I say round the result to one decimal place and paste the result to the console. That is, if this case is not met. So, but if this case, if the x you inserted into the function is not numeric, then this is what is going to perform. Then you're going to go to this line. But if that's not the case, then it's going to perform what you have under it here. So that's one way. And you can see here, I can drop braces. If I'm building a function that's quite simple that doesn't really need me to just write this. So you can see here, I'm creating an odd function. Say it takes one parameter x, then beside it, I just say x divided by 1 by x. I don't really need to write the braces here. If you write the braces, that doesn't mean it won't work. So I can just skip the braces and just do this. It's fine with that, but I actually like putting the braces. It makes it very, very sweet in a way. So I think the time is no longer on our side. I'll just continue from here. I didn't think I really make use of this time effectively, but it's fine anyways. I was able to cover much. So we are going to continue from the next slide next week. So using function application R part 2. So this one is the knowledge check. Suppose I created a function, I want to load it in the workspace by sourcing a script from the function. Which of the following commands used to look up the function that are present in the workspace? Just using the ls command, you're able to see all the objects you have created so far. So then we're going to start from here using arguments. So how you can add more arguments, add default arguments, and all of that in your function. So we are going to go from here tomorrow. Chidi, are you there?